We're going to take some time here and explore magnets and what exactly they are and how they work. So the basic idea behind a magnet, or a magnet is an object that exerts a force on other magnets or very specific types of metal. And most notably, iron is kind of the main metal that magnets will exert a force on. Magnets consist of two poles, and those poles are north and south. And this is because traditionally magnets were used in navigation. They still are used in navigation. And so they called the one that would point towards the north pole of the magnet, and they called the one that points towards the south pole of the magnet. And if you're wondering why that is, that's because the Earth itself functions like a very, very large but very weak magnet. So poles are on opposite ends of a magnet, and I'm sure this is hopefully no big shock to you, but if you've seen a bar magnet before, one end will be north, the other end will be south, and like poles will repel or push away from each other, opposite poles will attract. So if you have two magnets and you bring the north and north close, they'll push away from each other. If you bring south and south close, they'll push away from each other. But if you bring the north and south close, they'll pull towards each other. However, both magnet poles will attract metal. Will attract those specific types of metal we mentioned earlier, and this is for what we call ferromagnetic metals, because those are metals that can have magnetic properties to them. Now, this pair of a north and south pole is known as a dipole. So the north plus south pole, that like single unit of magnet, is a dipole because it's got two poles, dipole. And what's interesting about magnets, if you cut a magnet in half, each half will become its own dipole. And the reason for this will make sense when we talk about what the structure of the magnet is. So if you cut this magnet in half, we'd have a small north-south magnet and another small north-south magnet. So let's talk about how you make magnets, and this will help you understand what's actually going on inside of a magnet. So ferromagnetic materials, like I said, the main one of these is iron, are made up of clusters of atoms that form dipoles. And these are called domains. So they're clusters of atoms because in a ferromagnetic material, each individual atom is a tiny dipole. So if you get a bunch of those that are kind of all pointed the same way, then that chunk of material will also be a dipole. And so normally these dipoles are pointed in completely random directions, so they're all kind of canceling each other out in aggregate. So to magnetize, or to create a magnet out of that piece of iron, you put it near a magnetic field, and then you can do one of two things. You can heat it or strike it. So if you just hold that metal aligned in a magnetic field and you just smack it with a hammer long enough, it will become magnetized. So the energy that you added either by heating it, that's kind of the easy way to do it, or by striking it, by smashing it with a hammer, causes those atoms to be able to jiggle a little bit. And those domains will end up aligning with the magnetic field. So the big magnetic field that you've created, that you're kind of putting the iron in, the jiggle, and then it'll kind of land back randomly but closer to alignment. And then once you align enough of those, you create an overall dipole, and the object itself is now magnetic. So here's an illustration. So when we start out, we've got all these chunks in part A here, all these little bits of magnet where, say, in this region, a bunch of atoms are lined up so that their north is pointed up, their south is pointed, or is the downside. But over here, we've got a bunch pointed, perpendicular to that. And they're all pointed in random directions. And you'll notice, say, for example, this section will cancel out with the top section. If we zoom out, because this is zoomed in really, really close to the object. So if they're not all pointed in the same direction or mostly the same direction, parts will cancel out and we don't have an overall north-south. But then if I have a magnetic field pointed like this, so this has got to be created by something else. So say we'll talk about later how you can make magnets. If I've got a magnetic field here and I hit it with a hammer, well maybe now this top right one is pointed more kind of up and diagonally, and this guy's pointed more horizontally now, and this one's pointed up and diagonally. And you can see they've shifted a little bit because I added some energy and I allowed the atoms to wiggle a little bit, and more of them sort of align themselves pointing north-south. And if you want to get really technical, it should actually be that we want a south-north because they're going to match, they're going to match up, but that's beside the point. But if I do that long enough, then I'll get these larger regions where more of the stuff is aligned and more of these are generally pointed towards that north-south direction. Not all of them, but most of them will be more or less pointed up-down, and that means overall the material has an overall magnetic dipole. So that's how a magnet works, and that's what a magnet's made of. And so this is why if I cut this magnet in half, you can imagine cutting this in half. Well, what do we see? Well, the top half still has all the stuff pointed up and down. The bottom half still has it up and down, so each piece is just the same as the thing before, just smaller. So that's kind of the big overview of magnets. Let me know if you have any questions.